Hello, class. Here are your notes for Monday, October 15th. You should have your notebook out just like a normal day. You can see here we should be on page 44. The learning target we're going to write down is this. I can outline the layers of the Earth and describe the force that moves plates. Make sure you guys get that written down. Your TAD today, you'll see you have no homework. Make sure you pause this if you need more time to write this into your notebook. Okay, on your warm-up sheet, you should have that out as well. Make sure you have the correct date, October 15th. So the warm-up today says, now that you know about continental drift, what do you think the Earth will look like in another 250 million years? It says, draw a picture. So, if you think back to what we did last class, here's Pangea. You can see that all the continents are all as one. And today, this is what they look like. They are spread out. You can see South Africa and North America have gone this way. Europe, Asia, and Africa have gone this way. So the question asks, what do you think it will look like in another 250 million years? So pause the video now and complete your warm-up. Okay, you guys should have a note sheet. It goes through this video, and I will prompt it to stop and record your notes as we go. So let's start by just talking about layers really quick. I know you guys did this last year in 6th grade, so it's going to be real quick. So at the top of your notes, you should see some vocab words. The first one is the crust. You guys can write down this, the outermost surface of the Earth. If you look at a picture of the globe, you can see the crust is the outer layer. An analogy of how big the crust is if you think about the Earth as an apple, the crust would be about as thick as the skin on an apple. So it's pretty thin compared to the rest of the Earth. So the crust is the outermost surface. The next vocab term is tectonic plates. So the plates themselves, they're made of the crust. They're these big old rafts that you see here that are sort of floating at the surface of the Earth, and they are made of crust. They're made of a little bit of mantle too, but mostly made of crust. So pause the video now and make sure you guys get these vocab terms in there. Okay, the next layer we're going to talk about is called the mantle. This is the third vocab term you should see there. Make sure you guys get this written down. The definition I want you guys to write is this. The mantle is between the crust and the core, and its rock is like hot asphalt. So if you think about, here's the crust on the outside, this green, and the core is the inside. All this white stuff here is the mantle. And if you can think about hot asphalt is very movable. You can spread it around. You can kind of change its shape a little bit. And that's important. This mantle must be movable because it's of one of the things it does for plates. So pause the video and make sure you guys get this written down. Okay, so how does mantle play a role in our plates? Let's take a look. Now, you don't have to write this down, just listen and watch. So if you think about the Earth here, here's the core, here's the mantle, here's the crust. You can see here's a plate. You can see this light colored, this tan color. This is a plate. So what happens is, because the mantle is like hot asphalt, because it can move around, it's able to sort of expand and rise, kind of like when hot air expands, it rises and goes to the top. We know that cool air sinks and goes to the bottom. The mantle is very similar. When it's next to the core here, you can see this red arrow. It warms up, and we know that hot things usually rise. So this mantle will rise up like this. And as it does, it cools down. You can see it starts to become kind of blue. And then it cools off, and then it sinks back down because cool things sink. This is what we call a convection current. And convection currents are important because you can kind of see, if it's right underneath this plate here, you can kind of tell the direction that the plate will be moving, right? You can see this red rise, go across, cool down, and then sink, and then kind of just keeps going over and over and over again. So the next thing on your notes is a box that says, what is the force behind plate tectonics? Here's what you need to write down. Convection currents in Earth's mantle drive the plates on the surface. Heated lower mantle rises towards Earth's surface. So if you think about this picture here, you can see these white arrows. This is rising mantle, and as it rises, it cools down, and then it falls down to the core and heats back up, and it'll come back over, heat up, rise, and it will just go on and on and on. And so this is what causes plates to move. You can see here that these magma plumes usually happen right at a plate boundary. You can see here's a plate boundary, and it will cause this plate here to move in this direction. Okay, so pause the video and get this written in your notes. Okay, the next thing it says is what is subduction. So what you guys are going to write down is this. Subduction is the sinking process of plates. Make sure that gets written down. So if we take a closer look at convection currents, again, here's that rising hot mantle. The red mantle is rising because it's hot. Usually it rises at plate boundaries. You can see that here's a plate boundary. You can see there's an opening here. And as it rises, again, it cools and it moves over and it starts to sink. Now you can see here this plate is going to be moving in this direction. Now you see this little tail here, it's going underneath into the mantle. That's what we call a subduction zone. You can see this mantle that's falling is sort of pulling it down with it. And that's important because subduction zones create a lot of tectonic activity that we know. So make sure you guys pause the video and get this written down in your notes. So, if you look at this big picture here, guys, you can see there's lots of convection currents happening around the globe. And as these occur, they move the plates. You can see here's two plates. This convection current's causing this plate to move this way, so with a subduction zone over here. And this convection current here is causing this plate to rise and move this direction and have this subduction zone here. So, yeah, this is just a big picture of it all. So what happens when plates move? They can create three different types of boundaries. Now, a boundary is when two plates interact in a specific way. Now, there's three ways that they can interact, and this is on the back side of your notes. So the first one is called a divergent boundary. So what is it? That should be in your notes. A divergent boundary occurs where plates move apart due to rising mantle. So they move in opposite directions. And what happens? What happens is mid-ocean ridges form when it's in the ocean, and when it's on land, rift valleys form. So pause the video and make sure this gets written in your notes on the back side of your sheet. So here's a picture. You can see here, here's a plate and here's a plate. Magma's rising up because of convection currents. And as it rises up, it pushes one way and one the other way. And you can see here right in the middle, it's like an underwater mountain range, not a trench, an underwater mountain range. That's what we call a mid-ocean ridge. As these plates are pushed apart, there's not like a big gap here. What happens is as this magma rises to the surface of the ocean, it actually cools down and forms new sea floor. So this is a divergent boundary. Okay, the next one is a convergent boundary. So what is it? It is when two plates move toward each other and collide. And when they collide, they can do two things. They can either form mountains or they can form a subduction zone. So let's write this down in our notes. So two plates move toward each other and collide if it's a continental, or they subduct when it's in the ocean. And then what happens? Continental plates, they collide and rise. And if it's in the ocean, one plate will actually go underneath the other one, and we'll create what we call a subduction zone. So pause the video now and get all of this written in your notes on the back of your sheet. So here's here's a picture of what happens in the ocean. Here's a plate and here's a plate. This one's moving this way. This one's moving this way. When they interact with each other, one plate goes down, and as it goes down, look what's happening right here. It's starting to melt. This plate, as it gets lower in the mantle, it starts to melt. And as it melts, magma starts to rise. And you can see we get volcanoes that are created. And usually this occurs in the ocean. If you think about the islands of Japan and the Philippines, they are a lot like this. There's a subduction zone happening right near those islands. This is a convergent boundary. Now, if it happens on two continents, meaning two land plates, what happens is they collide and they form mountain ranges. So instead of one going underneath the other one, the two will hit and move up, and they'll actually go upwards. And so the Himalayan mountains, that's how they were created. The Indian plate has been moving northward and collided with the Eurasian plate and caused the Himalayan mountains to form. Okay, last one, transform fault boundary. So what is it? Two plates slide past each other in opposite directions. And what happens? The plates can rub and cause earthquakes. So this plate up here is moving in this direction, and this bottom plate is moving in this direction. So this is called a transform boundary. It's almost like if your hands are moving, one goes this way and the other one goes the other way. This is what a transform boundary looks like. It goes like this. And so as they rub on each other, they can catch. And as they catch, they can build up tension and cause earthquakes. So pause the video and get this written down. Okay, here's the rest of your directions for the day. Make sure your name is on this note sheet. You are handing it in, and I will be checking it, so make sure that it's done completely. If not, rewatch the video. When you're done, wait quietly until everyone has finished and turned it in, and then you guys will watch the colliding continents video as a class, and you'll also be answering video questions that you will be turning in, so make sure you guys do a good job with that as well.